Yo, hey, what's up, viewer? Welcome to day 4, hour 1 of nebulous development. I appreciate anybody who's actually managing to follow along in these videos. And I appreciate anybody who is actually interested in what this game is trying to accomplish. Real quick, I wanted to discuss something on a post I made on LinkedIn. I've been posting, basically at the end of every day, I'm just posting a link to the last video with a few hashtags and everything, and I actually had a few people who came down here and left some pretty positive comments, constructive comments. So I just wanted to come in here real quick and mention a few of the things. So Jared here was giving a suggestion about using collision layers to help filter out collision issues, which was happening when the scanner was over-triggering the planets. Another fellow named Greg then linked to a video, which I went and took a look at, and his video mentioned the same thing, and he showed how to go through and actually make layers for the collision, which it is something that I'm familiar with, but I definitely wasn't reaching for the layers system. So listening from these two fellows, it is something I should probably consider, because it was kind of in the back of my head, but I was ignoring it. And I can see where it can be very helpful to do this. I was considering it during the raycast code for selecting a new object, because I could filter the raycast for things that are only on the, basically on the game object layer, and then it would just ignore the UI. Is essentially one way that could have gone. So I was thinking about using layers at that point, but I didn't. Instead, I just used the mouse enters UI event thing. So then I left some constructive comments here. So yeah, I just wanted to mention that real quick before I started working on the game today, that I appreciate that I appreciate the help these people are offering. Alright, so the other thing I'm noticing is I do understand that there's times where I could probably make the content I'm creating more absorbable from my side. The game is coming together, and I'm kind of banking on the idea that soon enough the game thumbnails will look good enough that it'll be more clear kind of what's going on, and it'll be more interesting to watch. But these early stages are definitely not as interesting from the outside looking in, especially when I'm designing on the spot and thinking on the spot, and every once in a while getting lost on the spot. So I just want to be upfront with the fact that, and I understand this isn't tailored to be the most entertaining content you've ever seen. The idea is that this is going to help finish this game, and it actually already has. By recording the process, I stay focused for the entire hour, which is always something I've had trouble doing historically. And I never thought that recording myself like this in live development would help that problem in particular, but it's wound up helping. It just feels like you're under the spotlight, and you wind up focusing differently. So the main thing with that is I have to just make sure that I don't get stuck in an explanation land, trying to explain things a lot, which I feel like I wind up doing a lot. However, if I don't explain things, then there's going to be a silent void. So, there's a little bit of indecision going on for how exactly I want to present myself doing this. But the main thing at the end of the day, is that I'm actually accomplishing things, whether or not it's entertaining to watch. And that's what's most important. So for anybody who's, bothering to listen up to this point, I appreciate that you are willing to put up with that to glean into what is going on here with this game production. And as much fun as it is just kind of talking, I do actually need to use this hour to get some game work done. Alright, so as we saw earlier, more or less the scanning system it's functioning almost exactly as intended. The scan actually does find celestials in the system, which is pretty cool. These celestials are then selectable, courtesy of the prefab system. I added the sun selector. It's just not very good, or it doesn't really feel like it makes the difference. It just makes a difference, so I'll have to consider that. So the last time, what I was doing right before I ended the video was I was actually going into the start screens files and I was grabbing this skybox, star skybox, to use for the prototype. And that will help give a little bit of energy for this. The other thing I needed to do was since I'm using the high dynamic render pipeline, I have to include I have to configure the global volume to use an HDR sky, and I can plug in the cube map. And I'm double checking that I don't have any. Here, let me just double check like this. I know I've got a global volume. It's kind of weird. It showed up and then disappeared. So I have a global volume asset, and this does have an HDR sky. The problem is hold on. Yeah, I'm not entirely sure here. Maybe I can just make it a sky here. No, it has to be running through the HDRI thing. Alright, so essentially I'm trying to consider if it needs to somehow. I know I've got to add a global volume profile, so really quickly I'm going to switch over to the start screen and let me take a look at if it has so it has a global volume object and it just has a volume component in global mode. So for simplicity's sake, I think that will basically be well enough. And I'm basically just going to carbon copy it over as opposed to have code shifted around. So I've got to open up Galaxy Generation Scene, and I need to create a global volume. I'm pretty sure I can do that here somewhere. There's a local volumetric fog. Here we go, volume. Just make a global volume. I don't mind resetting the transform to 0. It is in global mode. It does need a profile, so can I just reuse the other scene's global volume profile? Let me see. Okay, sweet. Pretty straightforward. And there we go. Yeah, now we have stars in our background. So let me set this to maximized, and then we will play this. Even though the starry background adds some depth, like having a more intricate background becomes a challenge, because if the player can actually potentially get to those places, they'll have to, like the scanner will have to be physically accurate to a certain extent. But for now, it actually just adds a little bit of spatial feel to the game. Although it did, now that, okay, so interesting, now that I added the global volume profile, the scan ring was really janky. So to fix that, we can just click on the shader graph for the scanning ring, or for the active scanner. So let active player scan, throw up in this, and yeah, it's emitting black, so it's, now that the volume's involved, it's actually coloring itself, as it should be. So I don't know, the color for a wave is like grayish, so let's just make it white for simplicity. And we can potentially change the color of the wave depending on the like frequency. So lower frequency can be red, so let's just start with red to kind of go down the route. And it is a mesh and it's got normals, so it should. Okay, so I'll admit this is something I'm a little shaky on still. I'm not like I don't super understand HDRP. I've read the manual a couple times and I've used it a little bit, but I am by no means extremely sophisticated in it. I understand that global illumination means that anything that emits light contributes to the light of things within the range of the light. So for instance, this sun's yellow should be lighting this up, which it might be just because, maybe it's just because it's white and I can't tell it's lighting up with yellow, but the wave that we launch should color to the color of the sun if it's lit properly. Okay, so that was weird. Oh, no, it's not weird because it's a low frequency. Okay, that tripped me for a second. But yeah, there's essentially like a low, so we can run out a low frequency scan, and then the idea would be that we could like cut the angle pretty low and then like but jump up the frequency, and then it could go up the color spectrum. Okay. So we'd have to see what happens with that. But the thing I still don't understand is if I put the sun in the middle of the screen and I turn up its HDR emission to like 16 or even higher, if global illumination is properly configured in the volume profile, then that acts as a light source for everything in the solar system, as if you were just using a directional light or just using a spotlight or point light. Sometimes you get spotlight and point light confused, but honestly, I'm just not seeing the global. Like, there might be a global thing here. Let me just take a quick look. There's screen space and global illumination. Honestly, I'm just not familiar enough with it to bother with it right now. But at some point, I can reconfigure that. I can reconfigure the sun to actually light to affect things in the game. So it's on my list, but I'm not doing it at the moment. So instead, what I would really like to do is, at some point, I'm just going to have to incorporate the frequency into the waveform. So more or less, anytime the frequency changes, we're going to have to potentially change. We're going to have to change a couple things, actually. we're going to have to change the lerp. So essentially the lerp's t value that increases the wave's radius will have to change depending on the frequency the player chooses. And in the event the player launches a scan, we effectively want to, we're going to have to change the color of the material. So we are going to have to open up the, once again, active player scan shader. And I'm already getting some warning signs that, or I'm starting to get some anxiety that this might share the material. So if there's multiple waves, changing the color might change them all to the same color if I do this incorrectly. So, but I'm not sure. They each have to have a material, and they're prefabbing off the same material. So this will, I might not have to actually do this in the shader. I might just be able to set its local color to a certain color instead. So let me drop the idea of using the shader graph and take a look at this again. Essentially, whatever the okay, so this is one that's pretty frequency bound. So we're going to have to take the current frequency value and here's where we're getting into like anatomically correct frequencies and stuff. So it's like I start to worry that someone who knows better will be annoyed if I say that a wave that is colored red isn't actually at a red frequency. So now I'm like, also if the player starts off with like a frequency of 2, but then increases their max frequency, then that's going to change where it's red. So if 2 is where yellow starts, but then they increase their max frequency amount, and that shifts to where yellow starts up to like 5, then the value of 2 now doesn't have the same color. So it's like, essentially what I'm imagining is the slower frequencies have the lower colors, and those are they're constant where they shift. So maybe from like, okay, so essentially here's what I'm thinking. The red wave goes slow, and then as it goes up, orange, yellow, green, blue, indigo, violet, the frequency goes up and up and up and up, and then as like, I guess arguably what I'm saying is if it passes violet, we can actually technically collapse the wave. And in a short-term sense, the wave would just be theoretically fast enough that it's arguable that it's instantaneous in local space. And if it is going into higher level space, it would still need a wave, just a white wave or something. So I'm almost feeling like this might be a little redundant, but it serves as player feedback for, it's subtle player feedback for the frequency that they've decided on. It's just coming down to this the balancing considerations. it would be really cool to color the waves. And increase, the other thing is increase the speed of the wave. Man, oh man, the easy way would be to just divide the total amount of range, max range, and then just like divide that by 7 or something, and then, or you wouldn't even have to do that, really. If you do, the problem with doing it like that, though, is every time the max range increases, we have the scaling issue with these frequencies. So I suppose, instead of messing around with the colors, the first thing I can do is just change the velocity of the scan. And that has to do with distance divided by frequency or something. Some kind of math where the distance, the same distance with less frequency takes longer, essentially. Which is going to get back into our active scan form. The radial adjuster, which is basically this. More or less, what has to happen is the frequency needs to have an effect on this iterator. And that is going to change how quickly the lerp completes, which means that if it's diminishing the delta time, it should if it's diminishing the delta time, it will make the lerp take longer. And if it's increasing the delta time, it will make the lerp go faster, because the iterator completes sooner. So if we multiply time to delta time times, and we could arguably just put the frequency here, because the frequency is capped at, or the lower bound is 1, so we can never accidentally go below 1 and diminish the frequency when we're supposed to be increasing it under this model by capping it at 1, or capping the minimum at 1. 1 or anything over 1 means that the frequency going up only ever increases how fast the iterator completes. Which is where having it be able to go below 1 would in fact make it go slower. So let's see how this looks. And we may have to simply add some kind of, maybe like a power function to diminish the, or to make sure that the change isn't linear, essentially. The other thing is this is kind of a secret buff or nerf to scanning, because it does change how quickly the scan comes through. But essentially here I need to go up to I'm going to have to use player data, and so player data, let me take a look what I've got on this. I think I have I have the active scanning frequency, which is a floating point. And okay, so if the number is greater than 1, then delta time increases, which means the iterator gets bigger faster, which means it's faster. The only issue I'm foreseeing is that I might want to have some kind of wait. It might be too fast at tier 1. We'll have to see. The idea is I want the early waves to be slow, so it kind of fits in with the player. Might have to be an extra diminishing effect. but this actually should effectively change the speed of the scan. I don't have to reference anything new, I don't think. Alright, so this should effectively increase the speed of the scan if the frequency is at 1. Whoops. I might need to get test economy for that. Okay, so that did slow it down a little bit. And I'm going to have to turn off maximized, go back to normally. And I'm going to have to cheat up the economy so I can test these scans a little better. So let's see, player data, total economy 500. And I think I can get that to reset at some point. Okay, good. It did. And so let's zoom out here and max up the angle. Fix the frequency. So it's still defaulting to 0 for some reason, and that is a bug I'll have to fix. Should be relatively easy at some point. However, at a frequency of 1, this is essentially as slow as it goes. And it's like too fast. But let's see if a frequency of 2 is actually faster like it's supposed to be. Okay, so 2. And it is faster, so 3 is like almost instant. Yeah, see, it's just way too quick. So even at 10 frequency, it's like... Burn down the economy, though. Alright, so... as I suggested, it's going to need... well, I guess it makes sense, though, if it's like... if you have a really small angle and you're just scanning down a planet or something. You just want that high frequency. Alright, so... I suppose it's going to need some kind of a... I'm getting some weird idea to do like a integer minus like an integer minus the variable and divide by that, and then oh, I think that might go in the wrong way. I just had to come up with a little bit of math to I guess the easiest thing would be to just go into player data. I'm gonna have to add a new variable. And it's just gonna be public float. And we'll just call it active frequency dampener. Or active frequency damper. Then we'll jump back into active scan form and we have to multiply by the damper. And this will allow me to diminish it linearly, but it's not going to curve it properly for balancing reasons, but it will provide an in general dampening of the velocities. So if I do this, essentially everything is 4 times slower. And then this will still be messed up, but I've got to fix it at some point. I'll probably do that next since it's interfering with this part of the game. So, oh, and I've got to cheat my economy up. Maximize the range. Tweak the frequency. So now this should go much slower. Okay, and that's more of what I'm looking for. So like the initial scans are much slower, and that gives the player a it gives them a way to cost effectively do AoE scanning. The downside to it is just that the scan takes longer. Is basically is kind of how I'm envisioning this. So the idea is they can do a big AoE scan, but it takes longer as it goes out into space. And that's also why I wanted to have the frequency increase the cost on not on a linear expansion, because if it's linear then you just can afford it, but if it's squared or something, then what happens is you have to strategically have the resources, or it's got to be a proper strategic decision using a higher frequency. If the frequency only scales linearly, then it's equal cost effect regardless of frequency, whereas the goal is to decrease cost effect of higher frequency scans, but you get the benefit of the scans completing faster in space, and you get the benefit of, usually what's happening is you're using that higher frequency scan to unlock a higher tier buff on the planet through discovery or something, or you're discovering an even harder to get resource cache of some kind. So the idea is that you pay more on the scan, but whatever you're scanning down is like a much higher tier resource, like resource cache or something like that. Whereas if it's linear, you can basically just skip to the high tier scans immediately, and the cost effect is the same as like trickling up. And that what essentially, I believe that it will help the game diversify its scanning. And it also makes some anatomical sense that you are, or it at least makes arguable anatomical sense that at a higher frequency could arguably be using exponentially more energy with how much more force you have to push into the wave to get it to go the distance. Like anatomically speaking, it makes some sense. It makes enough arguable sense that it will add enough without causing an uproar necessarily. I think it will work pretty good. And I was just going to try running a higher frequency scan here. Okay, now it's displaying accurately. Oh, but I wanted to run it up at 2 degrees. So let me jack up the economy again. I have to reset this. Man, there's times where I wanted to reset in multiple ways. I'll have to consider that. So here's a tier 3 scan. And it's just much quicker. I just have to shift the price. So I mean, honestly, I do want the price to be exponential. So I'm going to tweak a few things, and then I think I can make that work. And then it would also be cool to... Oh, I guess I better fix this really fast. So, trying to remember where that was initialized even. It was initialized perhaps on the active scanning elements, but I think I already looked and I did not see that. So then we're considering the player click selection button option. even in this instance, the value is 1. As for the frequency, yeah, that's what I want though. So if I select, that's very bizarre because it should automatically be setting to 1. That's very strange. I am confused as to why it's not working as intended. So if I run in here and I check the scanners, this is set to 1, but the frequency's actual slider is not. It is though. So it's properly set in the slider also. For whatever reason though, it's setting to 0 whenever the game starts, more or less. Which I'm not sure why that's happening. This doesn't do anything to affect it. Let's see here. So we've got. So if there's a scanning capacity switch, and then what happens is if there's not a scanning capacity, it still is supposed to set itself to 1, the low point. And then if there's nothing selected, it's still supposed to go to 1. So in all the instances of selection, it should go to 1 automatically. Hold on, I just got the thought for active scanning elements having in start and initialization. So maybe what I will do is first things first, take the scanning frequency and set its value to 1 on initialization. And then it might just be fixed from this point. Because for some reason it's not giving me 1 for the value. Alright, so let's give this a shot. So if I max this up, the price should barely go down as I increase this. It shouldn't jump, and it jumped. So it's still default. For some reason, it's defaulting at 0. I am not sure why that's happening. If I even look at player data, it's got all the active scanning values. And if I open this up, or if I go back in here, active scanning frequency doesn't start at 1 though. So if I select this, the active scanning frequency value is only 0. Which I feel like I was messing around with that yesterday, wasn't I? So that's going to make the cost not change until this gets changed, because it thinks it's 0. So let me come in here and set this to 1 by default. And that might be all I need to do to fix that, because everything else is basically already correct. And the initialization I didn't have to write in that little initialization if I had just done it here. So now if I grab the scanner and increase the range, it should actually cost more. But it isn't. It's having no cost equivalated to it. Okay, that time it did the... Okay, so it's almost like, okay, same derp-de-der, the same exact thing is happening here. I have a default scanning angle set, but I haven't defaulted it in this regard. So now everything should be proper. Just increasing the radius of the scan by default should properly cost something. Although it isn't. Oh. Once again, I know why. Okay. This has to be 75. Okay, now I think it's gonna work. And this is how we want it to work. It's a player courtesy. If they get instant feedback on how much their scan's going to cost from this idea, then they can have a pretty good idea of what they're trying to accomplish. Whereas before it was letting them make like a scan like this, and they wouldn't know how far over the limit they were until they came down here and changed stuff, and then they'd see that they were way overshot. But now it's not very fast in that one, huh? Not very fast. Alright. So that's getting somewhere. So okay, so that's proper round. So if I come out here, come back in. Once again, I can just get the scan and how much it's gonna cost. Alright. So I fixed that little issue. I guess I can come in here and yank this out. And now we are looking at okay, so now we're looking at maybe like adding in a multiplier for the cost of a higher frequency scan. So to do that, we would have to go into player data, and we called this active frequency damper, which I wanted to rename that to something else. I wanted to rename it to active scan travel speed damper, but whatever. We'll just leave it like this. Public float. So now we need to make a new value, public float, and this is a so we'll call it scan frequency cost scalar. And then we'll have to come into the code that price calculation code, which was in our active scanning elements. And if the frequency changes, the cost of the active scan is exactly the same, except for this value needs to be I basically have to go like this. I don't know if I can do this or not. I have to power it by the... I don't know if I can actually do that. Let me just do that. So player, I might have to just do mathf.power or something. Let's just see if that works. Mathf.power. So float to a power, which this is the float. And the power is our player data dot, and what did I call it? Cost scalar. Scan frequency cost scalar. And so essentially all this does is it's the frequency times a power value. Which, as we know, as the base increases, that increases it by more if it's higher, depending on the exponent. So as long as the exponent is positive, it will return a higher cost per increase of frequency each time. So I hope that makes sense. And here we're basically just adding this, but we just want to take the player data's active frequency. Oops. And that is going to be the same up here as well. And I know in the long run, power is not as efficient as certain forms of multiplication, but I'm not too worried about it for the moment. Oh, whoops, did I just... Sorry, I'm tripping just a little bit. Okay, so then we can do the exact same thing here. It's just active scanning frequency powered to the scan frequency cost scalar. This just adds a little bit of organic effect to the game. It adds some trade-offs to the scanning system. Otherwise, it's equal cost effect at every frequency, so it just makes the player... It adds a smidgen of risk for using higher frequency. Because if you tank all your economy by doing high frequency scans and it doesn't pay off, then so be it. Whereas if you use the patience of lower frequency scans, it's more cost effective. So it's like, I just like that exponential growth on the cost of a frequency scan. And this should work. I should now be getting higher frequencies should sink the economy way harder. Okay, so frequency 1. And if I start jacking up the frequency, it is not actually working. What do you know? Oh, and I know why, because I didn't change the power to be anything. So, I guess the easiest thing would just be to square it. The number that really came to my mind, though, was this one. For now. But in the long run, it could be much higher, for sure. So we can buff this. And 1 to any power is 1. Whoops. So I'm wondering why the cost is so much greater now. I'm not sure, okay. But the idea is that increasing this should be doing way more. Start at 1,000. So it goes from 1,100 to 500, from 10 to 5-ish. But then from 5 to 1, it'll go from negative 500 to about that. It doesn't seem like it's really multiplying that much. Let's just see what it is maxed out then. It is more if I max it out. That's in the 5,000s. It just doesn't feel, I don't feel the difference. So let me just jack this up to 2 then. If I jack it up to 2, then power is equivalent of there and yank the math power and just power it to itself, which I was watching in a video that actually means that the hardware itself, or like it doesn't have to do like a power operation, which is whole steps more expensive than just doing 2 multiplications. So very nuanced, but perhaps something we could consider. So now in this case, if it's maxed, at a frequency of 1 is about 300, if I start jacking it up, now you can feel the difference. Quite heavy. Geez, now it's up to that. So that's a huge difference. So then they can see this and see that there's a difference of 20,000 about halfway. And then as you get cheaper, it's only a 10,000 difference. And to the same point, this is like 10,000, this is only 3,000, so they can kind of understand what's going on here. So one can understand where pretty large area of effect scans cost more. Or they, how should I say this? Large area of effect scans are more cost effective if you use a lower frequency, is sort of the point. If you start trying to do super high frequency, large area scans, it winds up jacking the price up pretty hard. And I'm going to have to tweak this balancing, but it makes some sense here. If you really want to do high frequency scans, you're going to have to cut down the area pretty hard. And then this is where the locking on would make a lot of sense. And then you could perhaps, if it's at just the right spot, you could pull it off if you really needed to. Well, so it's now basically all controlled through here now. How much it costs for higher frequency and how much I can slow down the scan by. but that's starting to shape up as a pretty cool mechanic. That's how it's supposed to work. So the only other thing then would be it would have to be changing the color of the wave. In terms of anatomical accuracy, due to the fact that I described. So I could effectively make a range with like a gradient, sort of like a gradient, or like not a gradient, but I could split the range manually, or I could recalculate the range based off of the max scan value. It would be nice to keep the synonymy though. If you see a red wave, it would be nice to know what that is. Not have to worry that it's like maybe 3 times bigger than a different, or 3 times faster than a different red wave, and it's just colored red because of how it's scaling. So I feel like it's got to be consistent values. So my idea at this point would be we could almost shift the max frequencies to 7, and each frequency is a color. And that would decrease how much scan frequency there is. We could leave it at 10, and we could add invisible colors. Or invisible frequencies, so like X-rays and gamma rays. And then just shift from 1 to 10 across the visible color spectrum. The only issue then is if it changes. So like, perhaps instead what we could do is start with a max frequency of like 3, and then from 1 to 3 is like red to yellow, or red to orange. And then if there's 3 frequencies per color range, then you're looking at what, 6 ranges if you go from red to violet and each one in between. So then you're arguably going up to 18 frequencies within the visible color spectrum, and it's consistent. And even that might be too many, so like that can even scale down if I don't need 18 tiers of frequency. Alright, not much time left in this video. I can even scale it down to 2 colors. And then you're looking at 12 or 9 total frequencies, or so that would be 1 to 10. And then it can expand a little bit here or there as necessary. That would just be a really cute nuance for the player, having the waves change based off their frequency. So if that's the case, then I guess we could start our max frequency as 2, and then 1 to 2 is red to orange, then 2 to 3 is orange to yellow, and then so on, 3, 4, 5, 6, 7, 8, or whatever. We could arguably, and then start at like 2 frequency max, and be able to increase frequency up to 9 or 10, which also increases the speed of the wave. So I think that is what I'm going to go with at this point. I will throw that together in the next video, and I should have it working pretty quick. So thanks for checking this out. I'll see you in the next one.